Look at this IIT level question. It came in IIT some years back. ABC is an isosceles right angle triangle. So these two sides are equal. And the angle is obviously 45 and 45. Right angle at C and given by Z1, Z2, Z3 for ABC. Z1, Z2, Z3. Prove that this is this. Now look at this. Z1 minus Z2 comes twice. Z1 minus Z3, Z3 minus Z2. You can make out that these are vectors. So Z1 minus Z2, Z1 is coming first. So angle towards Z1. So this is Z1 minus Z2 because Z2 is here, Z1 is here. Z1 minus Z3, okay, Z1 towards Z1. So this is Z1 minus Z3 and Z3 minus Z2, that is towards Z3 minus Z2. Now we'll use our facts that this is isosceles and this is 45 and 45. One attribute of isosceles triangle, right angle triangle is that if this is A and this is A root 2 and the angles are 45 each. So we'll have to use these facts given in the exam, in the question. Now using our angle division formula, we can write this angle anti-clockwise is in this direction. This is the anti-clockwise direction. So this comes first. So our first equation becomes Z3 minus Z2 by Z1 minus Z2. Whether the sides, now we have to find the ratio of the sides, because this is also R1 EI something, this is also R2 EI something, and R1 by R2 into e to the power I, the difference of the angle, that is the angle between these two vectors. So R1 and R2. Z3 minus Z2 is the side A and Z1 minus Z2 is the side root 2A. So we get 1 by root 2 and E I pi by 4. Now we have covered Z3, Z2, so we can put a tick here. We can cover one of them. So now Z1 minus Z3. Z1 minus Z3 is this guy and this is remaining, so we'll try and connect that with this. But these two arrows are pointing here, which will not do. So we'll take the opposite arrows. We'll take the opposite arrows because it will simply be a matter of, so this opposite arrow Z3 will be Z3 minus Z1 and the opposite arrow here will be towards Z2, Z2 minus Z1, and this angle will take as anti-clockwise. So anti-clockwise is this direction, so when it comes to here it has to be this direction, so it has to be this direction, anti-clockwise. So again we get another equation anti-clockwise, which comes first, Z2 minus Z1, Z2 minus Z1 by Z3 minus Z1 equal to Z2 minus Z1 is the longer arm, A root 2, by the shorter arm, Z3 minus Z1. So this becomes root 2. And the angle is again the same, EI pi by 4. Now we have to get these two items together. We have to get these two items together. So we'll reverse this and multiply. We'll reverse this and multiply with this. So if I reverse that, we get Z1 minus Z2 by Z3 minus Z2, this is the first equation, equal to root 2 E minus I pi by 4. And this one is already there. Now we'll multiply these two. we'll multiply these two and see what happens. If I multiply that, then we want z1 minus z2, so we can put 1 minus here, and we get z1 minus z2 whole square divided by we want z3 minus z2 and z1 minus z3, so 1 minus more, 1 more minus z1 minus z3 into z3 minus z2. That's what is there in the question. And when we multiply them, root 2 into root 2 becomes 2, and this 2 becomes e to the power 0 equal to 2, and we have got our answer. Please follow the systematic approach that we had employed in this question of anti-clockwise direction to be positive, and the ratio of the sides we have taken each time, and the arrows. We have made the arrows such that it starts from a point, 2 arrows, and then we take the angle as in the anti-clockwise direction. Here the arrows were pointing differently, so we just reversed it, because the reverse direction is simply the negative of that, so we reversed it negative, and that's how, and took the anti-clockwise direction to make the theta as positive, and put the arrow towards the angle arrow towards the vector on top. These are the small things that we done, and these are all very, very important, and it's just a little bit of practice